Hi, my name is Nyareen, and today I'll be going over my recommendation report oral presentation. My topic is how the United States can capitalize on its massive wind energy potential. So let's start with the introduction. So the United States actually has the greatest potential of driving the global transition to renewable energy. And among all the renewable energy sources the nation has, wind energy has the highest potential for growth. So my key areas of focus, first we'll be looking at improving the current wind technology we have, and then moving on to looking at the new or recent advancements we have in the wind industry. And finally, we'll be looking at ways to identify high wind resource locations or areas. So this is some background information. So let's start with the horizontal wind axis turbine. It's the most common turbine. It's in the photo in the back, and you probably have seen this. So the only issue with this is it has a really high operation and maintenance costs. Seeing that these things are extremely huge, therefore the transportation cost is a huge issue. Looking at our historic trends from 2010 to 2018, wind energy electricity generation actually tripled. So that's very impressive. And currently, we have enough wind energy capacity to power 33.7 million American homes. So for the problem statement, our years of reliance on fossil fuels has led to increased carbon dioxide emissions and consequently global warming. Now wind energy solves this issue because it's a clean source of energy. So moving to the analysis section, we'll look at the recent technological advancements in the wind energy industry. So we'll begin with the spider float offshore platform system. So what this is it's a platform, floating platform that supports wind turbines on the ocean. So basically each float that you can see, there's 3 floats here, each float is tethered to the ocean floor to prevent it from moving. So conventionally what we did was we had steel structures to support these turbines that span the entire length of the ocean floor. So that amount of steel is very, very costly to maintain and also to mass produce. So this is a good cost-effective solution. The only disadvantage with this is because it's a floating system, it's susceptible to the movements of the wave, which can interfere with the transmission of the wind energy and also possibly damage the components of the wind turbine. Moving into the vertical axis wind turbine is another recent development. It's very similar to the horizontal axis turbine, which I talked about earlier. So the biggest advantage of this is that it's smaller and it's shorter. So installation costs, maintenance operation costs are all significantly lower because of its smaller size. They can be placed closer to one another, which makes it perfect for residential and school areas. The disadvantage though is it has a lower efficiency because it's smaller, and because it is shorter, it captures less wind. So how this works is the higher your altitude, the higher the wind speed. So because it's on a lower altitude, it captures less wind. Let's move into the second part of the analysis where we look into ways to improve the current technology. So this is the aero robotic blade inspection system. So what this system does is it inspects the turbine blades using telephoto cameras and ultrasonic imaging. So why this is special compared to other pieces of technology is because it can detect subsurface damage. So subsurface damage is damage that cannot be seen by the human eye. So conventionally what we did was we had human piloted drones to view these damages in real time, but you cannot detect the subsurface damage. So this equipment can detect this damage at an early stage to prevent this damage from growing into a critical size, and then the operation and maintenance costs will be really high and the turbine blades might have to be replaced. So it saves potential costs, and it also can perform these inspections at a lower cost. The only disadvantage is that these robotic systems are quite new and they are still in their manufacturing phase. The third part of the analysis will be looking into ways that we can find high quality wind areas. So this is a LiDAR technology. What it does is it's basically a boat that we will deploy in a ocean radius, and it will collect oceanographic and meteorological data like wind speed, wave speed, wind temperature, and things like that. So why this is important? Because it's because that wind developers need to make informed decisions about whether to establish a wind energy site. So the advantages of this system is it can capture wind speeds at turbine level height, which is 200 meters, which is pretty tall. And this is one of the most key data points that is needed to establish an offshore wind farm. So the disadvantages is that it's really expensive, and this project alone costs 1.3 million. So to deploy many of these will cost a lot of money. As a conclusion, wind energy has massive amounts of potential in the United States, and operation and maintenance costs is the area that we can reduce costs the most. And we should also try to identify high wind resource areas so we can establish wind energy farms. So my recommendation is that the vertical wind axis turbines, the smaller ones, should be used in residential areas and school campuses whenever possible as a first step, because they are cheaper and they can power the entire campus or entire radius of the residential areas. And offshore wind energy should be given more emphasis because it has a greater capacity compared to onshore wind. And the oceans in the United States are quite vast, so we can take advantage of that. So here are some references. Thank you so much for your time. Have a great day.